All right. So with adding rationals, what we're going to do to add or subtract, we'll subtract tomorrow. To add rationals, remember what a rational number is? This is what we did day one, first notes. Yeah, Christopher?
It's something that can be multiple.
Nope. Good try. Perla?
Rational numbers are numbers that can be expressed as a fraction of two integers.
Good. Can be written as a fraction. Fraction of two integers, so it can be written as a fraction. So rationals are working with fractions and decimals. So what we're going to do is we're going to follow these simple steps, right? So let's do a quick review. We don't need to spend a whole lot of time adding and subtracting decimals. You don't need to write these down unless you feel like you really need to get them written down. So the idea is, whenever you have adding or subtracting decimals, what's the key rule? Line up the decimal points. Once they're lined up, now you just add in. Now you can fill in the missing zeros if you want. There's one missing zero here that we often forget, right? Here's a zero there. And we have zeros here. Hey Chase, can you close that door for me? There's another zero, some more zeros there. We call these placeholder zeros. Placeholder zeros. Those are just zeros to make sure that we keep the correct number of decimals. And we add or subtract with these. The idea is just 8 plus 0, 7 plus 5, carry the 1, etc. Right? When we subtract, the same thing is true. We just need to make sure that we borrow. You can't do 0 minus 5, but you can do 10 minus 5, right? Where's that 10 come from? Well, we have to borrow from here. Well, we can't do that, so we have to borrow from the cell. Or excuse me, 8 becomes 7. This becomes 10. Still need to borrow, so 10 becomes 9, and this becomes 10. 10 minus 5, 9 minus 2, and 7 minus 2. Questions on that? Okay, cool. Let's remember our integer rules that we've been working with, right? So our integer rules for addition, right? What's our add wrap? Ready? Go. Same sign, add. Different sign, subtract. We keep the sign of the bigger one so you can be exact. What? Exactly. So you can be exact. So that should say that. That's our idea. So if we're going to be adding, we add wrap, right? If we're going to be subtracting, we've got two ways we can do it. Who remembers one of them? Yeah. Keep change the sign. What's the other one? The one that I prefer. Yeah? The circle method, exactly. So we've got our subtraction, we've got our keep change, KCC, or circle method. Whichever one works for you, whichever one makes more sense, you just pick one. And then once you've done those methods, then what do? You add. With subtraction, all subtraction is just addition with this step. So all subtraction is you keep change it to addition, or you circle them up and keep them set up. Who farted?
No one. I said, shut your mouth.
Because you couldn't hear. That was really nice. Did you elbow him in the side too? Did you elbow him?
He was
Ha!
trying to sing.
I was singing the song too.
That's good. Keep change the sign.
Just
Good.
stop.
Cool.
I'm trying to remember it.
So here's our first example. Okay? So we're still doing a fraction review. You guys, not a huge deal about writing this one down since this one's subtraction. This problem is going to include every single thing we can possibly need in. Okay? This problem has every single thing. So this one is a full, all-encompassing problem. So, fraction review. Do we write the problem vertically? Not yet. So let's write the problem vertically. So we got 6 and 1/4 minus 2 and 2/3. Done. Is this an addition or a subtraction problem?
Subtraction.
This is subtraction, okay? So that's checked. So I got that subtracted. Find the least common denominator. What's our least common denominator? Between 4 and 3. It's 12, okay? So our LCD is 12. And we want to rewrite our mixed numbers with the same denominator. We call that scaling. So we have to multiply by 3, or we have to multiply by 4. And we get, there we go. Not sure why I did that so many times. There we go. It's acting slowly right now. 6 and 3/12 and 2 and 8/12. Bless you. All right. So we've done that. We've done step 4 here. You may need to borrow from the whole number when subtracting. In this case, we are going to need to borrow from the whole number. So 6 becomes 5. And I'm borrowing one whole value. What am I borrowing? I'm not borrowing 10, I'm borrowing 12 twelfths. Borrowing 12 twelfths. So 3 twelfths becomes 15 twelfths. Alright. So I've done that. Now I'm going to add or subtract my numerators. The denominator stays the same. So 15 minus 8 is 7 over 12. Add or subtract my whole numbers. 5 minus 2 is 3. And then reduce your mixed number if possible. Do I need to reduce this?
No.
No. And now, one thing that's not on there is double check your sign. What's the sign of our answer going to be? What's the sign of our answer going to be? Jace,
Positive?
why?
Because the first number is bigger than the second number?
Yeah, 6 is positive, and that's bigger than negative 2. Okay, it's bigger than negative 2. So, we just need to make sure we keep that sign positive. Keep it positive. You guys need to see Legally Blonde Musical, that's what it's from. Okay? So there are, all done. If you're unsure about how to borrow with a mixed number, we borrow 1 from the whole number and add the denominator to the numerator. Then we subtract. Okay? Okay. Questions? So that was a review. Now we're going to add or subtract decimals, fractions, negatives. We got a flow chart for us. Okay, so let's go down that flow chart. Is it a subtraction problem? Well, let's find out. So what do we got to do? If it is, then we keep change, or use the circle method. So now we're just looking at that flow chart. Follow along with me on the flow chart. Follow along with me on the flow chart. If no, we move on to step 2. All right, step 2, are the signs the same? So if the signs are the same, you're going to add those values. Your answer is going to have the sign of the numbers in the problem. Okay, pretty easy. If you're here, then you're done. Notice it says you are done. Okay, if the signs are not the same, okay, go on to step 3. Step 3, we want to make sure we remember that the bigger number is on the top. When I say bigger number, I mean the one with the larger absolute value. The one that looks larger. Not about positive or negative, just the bigger number. So the bigger number goes on top. Remember, if the signs are different, you subtract. Okay? Don't forget to get a common denominator and borrow correctly when you need it. When I say the bigger number goes on top, I'm talking about when we line it up vertically. Okay? And then, we just need to figure out the rat, right? The sign of the answer is the sign of the bigger number. Keep the sign of the bigger one so you can be exact. Right? So here are our examples. Let's go through the flow chart. So example 1. Is this a subtraction problem? Is this a subtraction problem? We're just going through the flow chart, everybody. Once you write that problem down, so you should be just working on this problem as you work your way down. Is this a subtraction problem? I need some yeses and nos, everybody. No, it's not. So what do we want to do? Go to step 2. Are the signs the same? No. So we go to step 3. The bigger number goes on top. So which one's the bigger number? Negative 8.57. So 8.57. Where'd that negative go? Hang tight. Hang tight. On step 3, it says the bigger number goes on top. Remember, since the signs are different, we're going to subtract. So 7.4. We're going to subtract. If you'd like to have your placeholder 0, it's probably a good idea. Before I do anything, I want to decide on my sign. What's my sign of this problem going to be? Keep the sign of the bigger one. So our sign is going to be negative. So we'll come back to that in a little bit. 7 minus 0 is 7. 5 minus 4 is 1. 8 minus 7 is 1. So we get 1.17 is our answer, right? Wrong. It's going to be negative because of the bigger one, so you can be exact. Okay? Don't forget to keep that sign in the bigger one. I find that it's really helpful to identify what the sign of our answer is going to be before you even do it. Before you do anything, it's really helpful to figure out what the sign of our answer is going to be. I bet you can look at example 2 and figure out what the sign is going to be. What's the sign of our answer going to be? Positive. Okay, let's get number 2. So at the first one, step 1, is it a subtraction problem? No. Are the signs the same? Ooh, so what are we going to do? We're going to add. 19 plus 3, or 0.3 plus 3.16. Let's get our placeholder 0 in there if you want it. 0 plus 6 is 6, 3 plus 1 is 4, 9 plus 3 is 12, carry the 1. 1 plus 1 is then 2, 22.46. And then don't forget, our sign is positive, so we want to just leave that thing alone. Questions? Yes? So why do we have the 0 here? It's a placeholder. It's just so we know what to add to 6. We're not going to borrow from the 0 because we're not subtracting. We're adding. No, that's all good. That's a good question. All right, questions before we do fraction stuff. 2 more examples. Both of them are mixed numbers. All right, example 3, here we go. Let's go ahead and decide. Go ahead and write down the example. I'm telling you right now, we're going to have 2 more. Yeah, we'll have time. Once you get it written down, I want you to decide what the sign of our answer is going to be. Before you do anything, what's the sign of our answer going to be? Chase? Why?
Because you're adding negatives.
You're adding negatives, and a negative and a negative. I mean, you're starting off with a negative number, and then you're increasing it by more negatives, so you're adding more negatives to it. It's going to be a sign that's going to be negative. All right, let's go through the flow chart. Is it a subtraction problem? No. None of these are going to be subtraction problems. Why? Because the title of these notes today were adding rationals. So we're going to be going to step 2 on every single one of these. All right, are the signs the same? Yes, so we want to add their values, right? Same sign as. It's just the wrap. But I'm giving you this flow chart in case the wrap isn't sinking in for you, in case you're not remembering the wrap or you're not processing it the way I want you to. All right. For time's sake, I'm just going to blast through this one if that's okay. Okay, just to make sure that everybody gets the steps. Now we do need to get a common denominator, so that common denominator is going to be 8. Multiply the top one by 2 over 2. We don't need to multiply the bottom one, but if you really want to, you multiply it by 1 over 1. And we get 6 and 6/8, 3 and 1/8. Now this is addition, so make sure you add. 6 plus 1 is 7/8. 6 plus 3 is 9. It's not 9 and 7/8.
Negative 9 7/8.
It's negative 9 7/8. Draw that arrow, guys. I know it seems silly, but draw that arrow. It will remember you to keep the sign the way it's supposed to be. Many of you on your quiz did not, so fix that mistake. Yes.
So don't you put the first number like 3, 1, 8, negative 1, 8, the first on the
Vertically?
Yeah.
Can I recommend never doing that? Can I recommend always putting the bigger number on top?
So it doesn't matter.
It doesn't matter. It's called the commutative property of addition. Doesn't matter. You can change the order. That's commutative property. So what's 7 plus 4?
11. 11.
What's 4 plus 7?
4 plus
Let's do an even easier one. What's 1 plus 2?
3.
What's 2 plus 1? You see how it doesn't matter which order you put them in, especially when you're adding. Yeah.
I just gotta point this out, earlier said when, because we're just doing addition problems, we're always gonna go to step 2. No
Yep.
matter what, we're always gonna go to step 2, because we always have to move on to step 2. Just gotta point that out.
Absolutely. Step 2 is going to be a starting step for addition or an ending step for subtraction. Yep. Okay. Questions on that one? All right, let's do our last example. Okay? So write down that problem, and then as you write it down, decide what the sign of our answer is going to be. Don't say it out loud, just decide what the sign of your answer is going to be as you write it out. Alright, look up to see if your sign is correct. Do you agree that your sign is going to be negative? Why? Because 9 is bigger than 4. Now, is this a subtraction problem?
No.
No, this is an addition problem, so go on to step 2. Are the signs the same? Nope, so go on to step 3. Bigger number goes on top, so that means we're going to go 9 and 5/7. And we're subtracting, right? Because it says, remember, since the signs are different, you subtract. In step 3, it's subtraction, so minus 4 1/3. Now we need to get common denominators. 21 is our common denominator, so we need to multiply the top fraction by 3/3, and the bottom one by 7/7. And we get 9 and 15 21sts, and 4 and 7 21sts. Now we're subtracting, so 15 minus 7 is, say it out loud, 15 minus 7 is 8 21sts. 9 minus 4 is 5 21sts. One note you might want to add to the bottom of your flow chart. A lot of people are going to stop here because they're like, I did it. Because it says you're done, right? Don't forget your sign. Okay? Bring that puppy down. Forget this is a negative answer. We identified the sign at the beginning to help us remember that it was going to be negative. Okay?